very important for the concept of the solution. It is stated that the partial pressure of IIT liquid is directly proportional to solubility. Means pressure proportional to solubility. The partial pressure of the liquid is directly proportional to the solubility. It can be also implemented in case of gas also, and this is very applicable concept. Works in cold drinks, in cold drinks pressure increases pressure increases the solubility of CO2 is also increases. By increasing the pressure, the solubility of the carbon dioxide gas dissolved in the cold drinks also increases the solubility. This is the first application of Henry's law. The first application is clear because the cold drinks is very popular at this time now in all over country, not only in country but also all over world. Is it clear? Any concept remaining? No. Look forward. The second application is in the mountaineer at the high altitude. The pressure decreases generally decreases, so solubility also decreases. Solubility also decreases. Everyone knows that going to the high altitude from the surface of the earth, the pressure decreases, and due to decreasing of the pressure, the solubility of the oxygen in the blood will also decreases, and the mountaineers suffering from problem and many other physical and their body problem. This is due to the Henry's law. I would like to clear that the Henry's law is clear now. The main point is that the pressure is directly proportional to the solubility. In the other word, we can say the solubility is also related to the mole fraction of the liquid. That is why the pressure is directly proportional to the mole fraction. We can say also pressure is directly proportional to its mole fraction. P is proportional to X, A component, or P is proportional to X, B component. X means solute and B is the solvent. Increasing the amount of solvent and solute pressure, the partial pressure also affected. So I would like to say about Royle's law. Before being explaining the concept of Royle's law, uh, we have to know about vapor pressure. Vapor pressure. Vapor pressure at the surface of the liquid arises the surface of the liquid at equilibrium condition. Equilibrium condition when the temperature is constant. When the temperature is the vapor pressure is the pressure exerted at the surface of the liquid at the constant temperature in the equilibrium condition. That is called vapor pressure. Okay, which is represented as P not A. P not A. I mean to say vapor pressure of the component A. Why that? It could be solute or solvent. Now, Royle's law is stated that it states that the partial pressure of known volatile liquid is equal to the product of its vapor pressure and the mole fraction of each component at constant temperature. A student, be attentive towards the blackboard that the partial pressure of non-volatile liquid is equal to the product of its vapor pressure and the mole fraction of each component. Here is one point must taken that the temperature remains constant. Now I would like to explain it mathematically. Pressure is equal to vapor pressure into mole fraction. I mean to say P a component P for pressure, partial pressure of the first component is equal to vapor pressure E naught A into mole fraction XA. This is the mathematical representation of the Royle's law, which has been explained above to the formula. Similarly, PB is equal to P naught B into XB. As we know, as we know, XA plus XB is equal to 1. Do you know the sum of the mole fraction of the solute to the mole fraction of event is equal to 1? Any question? No? Look forward now. So XB is equal to 1 and this is transferred to this side. That is why it becomes XA. XB is equal to 1 minus XA or XA is equal to 1 minus XB. What we have to do now? This is equation 1 and this is equation 2. Put the value of XA in equation 1. What will happen? Put the value of XA from equation 2 to equation 1. What will happen? PA is equal to P naught A into 1 minus XB. XA is equal to 1 minus XB. This is written as this. Now, no problem, any problem. The concept will be clear now. After the calculation, PA is equal to P naught A minus P naught A into XB. This is transferred to this side and this transferred to this side. The negative sign will become positive. P naught A into XB is equal to P naught A minus PA. Now XB is equal to P naught A minus PA upon P naught A. This is the mole fraction of solute, and by using this formula we can calculate the mole fraction of the solute. Any question remains? Now let us discuss this with a suitable example which I solve here. Note down this. Solution of benzene and toluene having partial pressure 150 mm Hb and 50 mg each component separately equal weight to mix together. There, find the vapor pressure of solution. This is the question. Solution, a solution made by mixing benzene or and toluene having the partial pressure of benzene is 150 mmHg, 150 mmHg. This is the pressure of benzene, while 50 mmHg is the pressure of toluene. Separately. Separately means both components are separated together before being mixing. The vapor pressure is this. Now mix together in equal weight. Notice here, both having the equal weight. Now we have to calculate the partial pressure of the solution. How to solve this? Let us look forward. Mass of C6 at 6. C6 at 6 is the molecular formula of benzene. Do you know or not? Yes, no. Because the structure of benzene is like this. So the atomic mass of carbon is 12 into 6 plus hydrogen. Can anyone tell me what is the atomic mass of hydrogen? That is 1. 1 into 6. The final will be 72 plus 6. What will be happen after calculation? 78. This is the molar mass of benzene. Now the question is written in the notebook, so I utilize this space. Similarly, we can calculate the molar mass of toluene. Any one of you know the molecular formula of toluene? This is benzene group in which methyl group is added here, CH3. If one hydrogen atom from the benzene is removed here and the benzyl group is arises, and in place of that if methyl group is added, this is called toluene. So the molecular formula of this is C6H5, C6H5 like this, and now CH3. Molar mass of toluene is equal to 12 into 6 plus 1 into 5. 12 into 6 plus 1 into 5 plus 12 and plus 1 into 3. The calculation will be 72 plus 5 plus 12 plus 3. It would be 92. That will be 9. Molar mass of toluene and molar mass of benzene are calculated here. Note down. XA mole fraction of first component can be calculated as given mass, given weight upon molar mass of A upon given weight upon molar mass of A plus weight upon molar mass of B. In the question, you have noticed down that the weight of each components are equal. That is why we consider the weight is W. Then W upon 78 upon W upon 78 plus W upon W upon W upon 92. W taken as a common, then it becomes 1 upon 78 upon 1 upon 78 plus 1 upon 92 upon W. W is also taken as common from these two. These cancel together, and after the calculation of this, calculation shows that the mole fraction of component A, I mean to say benzene, is 5.41, while toluene has 0.459. Now, applying the P A is equal to P naught into X A. From the question, the A amount is the vapor pressure of A is 150 and XA is 0.541. PA is equal to 15 into 5.41. PA is equal to 81.15. 81.15. Okay, now similarly PB is equal to P naught B into XB. Also PB is equal to P naught B is 50 into XB is look here 4.0.459. PB is equal to 5 into 4.59. So 22.95. So the mole fraction, partial pressure, partial pressure of solution is PA plus PV. I mean to say PA 81.15, 81.15 plus 22.9 mm Hg. 104.1 mm Hg is the is the vapor pressure of the solution. This question is previously asked in IIT. So those students who is going for the preparation of IIT must have to understood this sum. Now I would like to give you idea about ideal solution and non ideal solution. Ideal solutions are those solutions which obey the Royle's law. Which obey the Royle's law. Obey the Royle's law. Such solutions which obey the Royle's law. In case of non-ideal solution, the solution which do not obey Royle's law. The solution which obey the Royle's law are called ideal solution, while non-ideal solutions are those which do not obey the Royle's law. Is it clear? No question? What is azeotrophs? A or azeotropic solution. Azeotrophs or azeotropic solution. The solution in which their composition does not change on boiling of liquid at constant temperature. After you boiling the liquid, the composition of solute and solvent does not changes. Such type of the solutions are known as azeotropic solution or azeotrophs. Now look forward. I will come very soon. Wait for my next video. Till understand the concept Thank you.